This conference will now be recorded.
Good morning. My name is Scott Galligan. I'm the Inside Sales Manager here at TXRX. I'd like to thank everyone and welcome everyone for attending our webinar series. We plan to present webinars approximately every 6 weeks on a wide range of topics. The topics and dates are still being finalized, but we'll work with our reps and make sure we send out invitations to everyone. This first webinar is a presentation on our TXRX field services. It will be presented by our field service engineer, Al Yerger. Al has extensive knowledge of RF and real-world applications. We'd like to keep these webinars to 45 minutes, so Al will present for approximately 25 to 30 minutes, and then we'll use the remainder of the time to answer any questions. If you have any questions, please ask them in the chat box. The chat icon is located in the upper right-hand corner. It looks like the little bubble circle there. We'll answer as many questions as we can after Yale's presentation, but if we do go over we want to keep in the allotted time, the 45 minutes. So any additional questions, we will send out an email to everyone with the answers once the presentation is over. With that being said, I will turn the presentation over to Al. Thank you.
Hello, welcome to the TXRX Broadcasting Network. My name, as he said, my name's Al Yerger. I'm the senior field engineer for TXRX, and we work. Obviously, we work with with all of the field services issues and anything else that comes up. TXRX has had a field services operation for some time now. I don't know exactly when we got all this started. I know that I joined the company around 14, 15 years ago. So we've been doing it that long. We believe we're the only company out there that has field services, or at least to the degree that we have, where we can get out there and help our customers with either with our products or with some of their other antenna site issues that they might have, without the necessity of them having to go and perhaps take equipment off the air, ship it back to a factory, and have it looked at and such like that. We also help you out with your interference issues. So what we do basically is we offer several different services to help you monitor and troubleshoot the RF environment. We have the ability to deploy technicians pretty much anywhere in the world, mostly in the US, but anywhere in the world. I personally have been to just about everywhere. Been to Europe, been to South America, Asia, doing things to try to help people with their communications problems, sometimes involving our equipment or sometimes just a problem that they have in general. We do a number of different services, like I said, and one of the things that we do, one of the most popular services that we have is spectrum monitoring. RF performance is difficult to predict, particularly on a new system where there might not be anything already installed. You could have all kinds of interference problems, such as ambient noise from power lines, or co-channel activity, adjacent channel activity, various kinds of noises, how the channel's being used, actual versus the FCC. When you go out and you get a channel, maybe the coordinator gives you a channel and says, here's a channel for your system, and this is your channel, and it's free of co-channel users for some distance out. Or the FCC database may show you, okay, this channel is clean. There's no licenses within X number of miles of the site. Well, then we can go out and deploy our equipment and measure what's going on at the site and find out that, hey, that channel is actually in use. And that can be very, very valuable information to get that done before the equipment is is designed and installed, because going back and solving a problem later can be much more expensive than dealing with it up front, even if you include the cost of the monitoring services. Now, when we go out to do the job and monitor, and obviously monitoring before the installation can identify a lot of very critical problems like I just mentioned. But when we go out, we have everything that we need. We have all of the monitoring equipment, spectrum analyzers, computers, etc. We can provide the necessary antennas and filters that are required. We have self-contained trailers for sites where there is currently no site exists. Really, it's just an open field. We call it a green site. It's just an open field or the top of a mountain someplace where there's nothing there. We can still monitor at that location. We have generators and we have battery power to keep everything running and to keep it backed up, to ensure that we get all the data that we're going out there to collect. Now, within the spectrum monitoring, we have a couple of different services that we can offer. The first of which is known as spectrum analysis and monitoring, which we affectionately call SAM, S-A-M, and noise analysis and monitoring, which we call NAM. And if either of those two things doesn't solve the problem, or you have a problem after the fact, we also have interference investigation services that we can offer, such as advanced spectrum logging and signal level mapping. Now, we're going to get into those a little bit deeper, just a little bit further down the slide deck here. Spectrum analysis and monitoring, the first of the two, SAM, its orientation is for high-level signal analysis. We're looking for signals that are from the maximum that the spectrum analyzer can handle, 0 or plus 10 dBm or something like that, all the way down to the minimum that the analyzer can measure at that level. In other words, if we're looking at plus 10 as a maximum, we might be able to go down to about minus 70, something like that. If the maximum is a little lower than that, we can go a little lower. But generally, what we have is a range of signals that are on the high side. And the purpose for those is to identify strong signals that are at the proposed site. This is to help to protect the infrastructure. And when you do these measurements, and then later you design go to design the multi-coupler and the pre-selectors, we know what we have to protect against. On the other side of the coin, we have our noise analysis and monitoring, our NAM. This is oriented towards the low side. It picks up at the low end of whatever the SAM can reach and takes us down to somewhere near the thermal noise floor, is as low as we can possibly get, to the lowest possible noise figure, which would be something where our target is equal to or better than the minimum sensitivity of your receive system. This tells us what the noise levels are at the site. Particularly in the VHF band these days, there's a lot of noise. We see lots of noise in the VHF band that wasn't there 20 years ago. For those of you who might have been in the business a long time, VHF used to be relatively noise-free. Now it's nothing for us to see 10 or 15 dB of degradation out at a site due to environmental noise. So having that information before you design the system and before you predict the coverage will help you obtain an accurate coverage survey where you can tell the customer, this is the performance that you can expect. So to properly set expectations for the performance of your system. We can pull other things out of that information too, such as transmitters on site that might be generating a lot of transmitter noise, or maybe interfering in other ways with your system, either that's already there or the proposed system. Now, when we're done with all of this monitoring, and we usually go out and monitor for about 24 hours at a site, that gives us a good view of what's going on at the site for the average day. We also tend to monitor during the week. We try to avoid the weekends and avoid holidays because the traffic patterns on those days is usually different. But on the spectrum analysis side, we'll generate a report. The report's got a lot of information, and I'm just going to hit on a couple of things here that I think are the things that are of most interest to most people. And that would be what we call the spectrum power distribution. This is like a spectrum analyzer that's been operating in the max hold mode for 24 hours. And it shows you the signal level versus frequency. So this is amplitude versus frequency, like a spectrum analyzer, and it shows us where the high level signals are. So in this particular example, which was actually pulled from a real field measurement that we did for somebody, we see that we have a number of pretty high level signals here, some of them at or exceeding 0 dBm. This gives you a good idea of what to expect at the site. If your receive frequencies are falling somewhere in this lower part of the spectrum, there may be some problems that need to be addressed, or there may be some protection that needs to be built into your multi-coupler pre-selectors to protect from these high-level signals. Now, if you're up here at the higher end of the band where the signals are lower and we don't have those high-level signals, then the situation might be much better. We might not need all that extra filtering in the pre-selector. So now, of course, what's going on your particular frequency is a different factor. This shows us the overall. We also have what we call frequency reports, spectrum frequency reports, which shows us the activity on specific channels that the customer is interested in. We can see that this is a very busy channel. In the middle of the day, it was almost continuous duty. Even in the overnight period, it was quite busy. It will tell you what's going on the frequency. If a coordinator gave you this channel and said, hey, this is a clear channel, and we go out and measure it, and this is what we see, we know right away we have a problem. So before we even start constructing equipment, we know that there's a frequency issue that needs to be dealt with. On all of these signals that we find, when we find the high-level carriers, we will pull from the FCC database whatever information we can find on that. That'll show you, find on that frequency, that'll show you any transmitters that may be licensed on that frequency at or near the site. We also have an inactive channel report, which will show you the channels that we believe are vacant. You wouldn't use that report by itself, but it does show you something that you can send to your coordinator or your frequency spectrum person to say, like, hey, here's some channels that you might want to look at to see if we could license those. The other side of the coin, the noise analysis monitoring, the other half of the spectrum monitoring, will also generate a report for that. We have one of the most interesting charts that will appear in that report is the channel, the noise channel chart here that shows you each of the frequencies that the customer indicated to us they were interested in, and shows us the noise level that is present at that site on each of those frequencies. So we have each frequency individually, and then we boil it all down to a median value for the system to get it down to a single number. These are numbers that you can plug into any coverage program, any coverage propagation prediction program that you might have, that will allow you to get a very accurate view of what the coverage is going to look like in the presence of the real world noise that's at the site. We also have a chart here that is like the spectrum analyzer view that we had with the SAM, although it's based on individual frequencies. If you have a lot of these and they all packed together and across the screen here, it will start to somewhat look like the spectrum power distribution report from the SAM, but it shows us the amount of external noise, and it gives us the projected effective receiver sensitivity for each of those frequencies. We also have another frequency report, again, an amplitude versus time report covering 24 hours from midnight to midnight, that shows us what the noise levels were at the site and how it changed over time. In this example, we had more noise overnight than we had during the day. So again, more information that makes the design and operation of the system more realistic. If all of that doesn't work out, or if we do all of that, or you don't do all of that, and then you construct the system, or sometimes if you just find out through the SAM and NAM monitoring that there's problems out there that you want to further investigate, we can provide interference investigation services either on site or remote. For our remote monitoring, which is a very popular service, one, because it's been very effective, and secondly, it's a lot less expensive because we don't have to send boots on the ground. So you're not paying for airline tickets and hotel rooms and people to be out there full time. We send out the piece of equipment and we work closely with the people in the field and set up this equipment to monitor the spectrum. Now, the equipment contains a computer operated spectrum analyzer, very much like our SAM. It's a subset, or it's been derived from the spectrum analysis and monitoring. And we can set this up and monitor the spectrum out there full time, for 24 hours a day, 7 days a week, for as long as it takes. And it allows us to see what was going on at the site at the time that there are interference events present. Like I said, we work very closely and very tightly with the customer's technicians or the vendor's technicians. If we're working with a major manufacturer to resolve problems in a newly installed system, we have to work closely with the people in the field. One of the first things they have to do is to make note of the time and the frequency, if possible, on which they experienced interference. Once we know that, we can go back to our analyzer traces and we can rewind the spectrum analyzer and look at what was going on the spectrum at that time and try to figure out what the nature is of the interference. Is it co-channel? Is it an adjacent channel problem? Is it wideband noise? Is it a high-level carrier popping up somewhere else in the band? Or we can discover anomalies with the system. We have actually used this system to diagnose hardware problems with a system in the field. We had one system that we were looking at that had a lot of problems. It would had various random talk out problems where the subscriber units in the field would not be able to receive transmissions. And everybody that had looked at it at some point assumed that it was some type of an interference issue. And so we brought our advanced spectrum logging kits, our ASL kits, to the job, and we started monitoring the spectrum. And what we found after looking at that over a period of a couple of weeks, we found that the nature of the problem was actually a standby site. The system had a main site and a standby site, because the operation of the system was critical to the customer's operation. So they had two sites. The problem was the standby site would sometimes decide it was going to turn itself on without being commanded to do so. It just decided it was going to go into business for itself and start relaying signals like the main site was doing. So if you have a main site and a standby site and they're all in close proximity to each other, basically you have two signals coming out, very high power on the same frequency, mixing with each other, causing the subscribers to not be able to hear the system. We did all of this remotely, diagnosed the problem, and I never left my office. So this was great from a perspective of solving the customer's problem at a very, very reasonable cost for him. He was able to take our information and then go back and find out the problem with his system and correct it, which was done rather quickly. We can also take this ASL kit and we can plug a GPS receiver into it, put it in a vehicle. The kit has its own internal battery power, run for a couple of hours. But we can also run it on a cigarette lighter cord in the vehicle. And we put in mobile antenna and a filter in the vehicle, and we can drive around in a given area and measure signal levels, measure noise levels at a number of different locations throughout the area, particularly focusing on areas perhaps where the coverage is not what the customer expected. And by doing that, we can identify the source of poor signals. Is it a low signal level? Is it a high localized noise level, or is it something else? We take the information and send it back to our servers in Angola, and we can then process that information and download it into a map where we would display the signal levels or the noise levels as different colors. And this is actually a map from a project we did in Montana, where we drove around and through all these different areas. And the greenish colors, those areas where the signal level was above a threshold that we believed was sufficient for good communications. The red shows weak signal areas, but that they already knew that, and that was expected. So everything on the signal level was as expected. We drove around and looked at the noise. Here, the yellow signals, the yellow dots indicate higher noise level. Green is below, the noise is below a level that we would consider to be acceptable. The other colors show the noise level being higher, but still it was not red. We have a few dots of red in here where the noise was high enough to disrupt communications, but it still wasn't the problem. We also looked at the signal to noise level. We compare the measured signal levels to the measured noise levels, put them together on the same map. That gives us a good idea of what was going on. What we determined through all of this, to make a long story shorter, is that the problem was not signal level based. It was not localized noise level based. What it was since it's neither of those, the next thing we turn to look at is multipath, where you get signals reflecting from different directions and arriving at the subscriber and canceling themselves out or causing distortion so that the system would not properly decode the audio. This was a digital system. And so by using this, we were able to determine the true nature of the problem. Now, if the remote monitoring doesn't work out for you, or it's more complicated than that, we can do on-site investigation, the so-called boots on the ground. Again, we work closely with the customers or the vendors, technicians and engineers to work together to resolve the problem. One of the things that we would like to mention, though, is that the ASL kit, the remote monitoring, is still a part of this. It's a key part. What we've seen and what I've seen over the years, and I've been in this business since about 1974, a day or two, and we find that when you go out on a site to resolve an interference problem, if you're going in cold, you probably spend the first couple of days at considerable expense to the customer trying to just get up to speed. What we usually want to do is to send out the ASL kit, work with you remotely over the internet, over the phone, to collect some data before the engineer has to get there. So what will happen is we use the ASL kit. We decide that, okay, we can't resolve the problem just with that information. We're going to need boots on the ground. We make an arrangement to do that. But by the time we get there, we already have a leg up. We're already deep into this investigation, and so we can be much more productive for our time at the site than we would be if we came in cold. Now, the difficulty in resolving things will determine the amount of activity that has to be investigated. But we found all kinds of things over the years, from intermod problems, like we said, with the remote site coming online by itself. We have signal boosters in oscillation. Those can be some of the most fun. When people put in signal boosters and don't set them up properly, and they go into various forms of oscillation. So that's basically a snapshot of our field services. For more information, you can contact us through email. We have our own mailbox that doesn't go to any one person in field services particularly, but it goes to all of us. Field services at txrx.com, or you can email me directly, Yerger at txrx.com. I would recommend the field services one, because if for some reason I'm not available to pick up your message, somebody will. Or you can give us a call on our main number, 716-549-4700, to talk to us on the phone, or to speak with somebody and have us call you back, because sometimes we're busy. So that's it. That was our presentation at the moment. We have other things we do in field services. We will be having other webinars on some of the other services that we provide, but those are for another time, because I've already exceeded my time limit, and I see a guy coming with the hook. So, any questions? We're gonna open. I don't see anything came through on the chat, but if anybody has any questions at this time, you can.
Yeah, Al, we did have one question that the question is the ASL remotely monitored by TXRX, or is it recording activity and then sent back to TXRX for analysis? If you want to explain that process a little bit.
Actually, the answer to all of those questions is yes. The equipment with the spectrum analyzer and the laptop computer takes every spectrum analyzer trace, and is logged to the hard drive. At the same time that's occurring, if we have an internet connection, which is really it's a very good idea to have a good internet connection. If we have a proper internet connection, we also send that data up through a program that we call trickle feed, and it's every minute the system will wake up and send all of that trace information up to our servers. So we have the information in Angola, we have the information in the computer. If something happens to that internet connection, we still have the information in the computer, so we can download it later. So we've put a lot of effort into preserving the data. I once told some of the guys like Kevin and our guys that go out in the field, I said, look, you go out in the field, you can come back without the truck, come back without the trailer, come back without the computer, but do not come back without the data.
Okay.
Is that covered, or anything else?
There was another question: is define a good internet connection.
For our internet connection, we use a cellular modem that we can connect then to outside antennas. We also have some Verizon cellular air cards, but it doesn't have to be a extremely robust connection. Anything 3G or up will probably be good enough. Like I said, if it fails, we still have the fail-safe of having all the data in the computer. If a wireline connection is available, a Cat5 connection is available at the site, so much the better, even more reliable and faster. But it's not just as long as it's probably a 3G connection or better is more than enough.
Okay. Question on cost. We have several services that Al described. On the SAM and NAM we have a flat rate fee for those, but you know, it will also depend on if we need a trailer on the ASL, just depending on timing. You know, that obviously anything that we do not have to deploy in the field, and we have, you know, we depend on the technicians to deploy the equipment. It's going to be cheaper if we do not have to deploy. But for any services that you're interested in, if you contact the field services at txarcs.com mailbox, we can give everyone a quote on any service you might need, and you know, we can work with you to figure out what the proper service is for the application. So
Yeah, the cheapest thing that we can do for you, the least expensive, let's not say cheap, the least expensive is the ASL kit with some remote engineering support. The most expensive thing is SAM and NAM with a trailer. And that gets pretty pricey. The price of moving the trailer around the country seems to be increasing at an alarming rate. So if there is a building on site that we could use, that'll keep your costs down considerably.
as far as locations where we can perform the services, we can not only go anywhere in the US, but we have, you know, we've worked in Europe as well as in Canada, and you know, depending on whether we can get the equipment there or not, we can go pretty much wherever we need to. So you know, we can perform. We've done the services in several states, probably dozens of states. You know, it's usually obviously in the mountainous areas, because the flatter the area, that you know, the least the less amount of sites you have to put up. But we have also worked in Canada, and as well, we did a project over in the UK, so we can, you know, wherever we need the services needed, we can make it work. As far as there's a question on how far we need, how much time we need in advance to schedule a trip. We usually will need about a month of time to work out the logistics of preparing filters. Some of these services, we have to set up filtering to protect the equipment and what we're monitoring. So we need time to set that up, get that equipment in the trailer, and then, like Al said, get the trailer to wherever the application is. If we don't need a trailer, that will save some time, but we like to have at least a month's advance notice for that. Let's see, was there any other? We do, you know, we do have some partnerships right now, some contractors that we work with in certain states. So we are always looking to find strategic partnerships with people that are located near where we might have certain applications. So if you are interested in becoming a contractor, you know, please contact us and we can work with you to set that up. You know, we have training. Al will provide training on the processes, the equipment, and all that. You know, we want to make sure that it will make sense. You know, that you're in the area where you're working, so that it's easier for yourself, as well as, you know, we don't want to provide training that you may never use again. So you know, we know that areas in the West, we have a lot of applications. So I just wanted to let you know. As far as ASL, we have a question on the typical cost for ASL. You're looking anywhere from $1,500 to $3,000, depends on what all is involved in that. Let's see. There's a question on the impact of COVID-19. We have had some difficulties. We are based out of New York, and our governor has imposed a lot of restrictions on travel. So unfortunately, that has caused some difficulties with us, you know, traveling to certain states. But we are trying to work with contractors where we can, and otherwise we will, you know, work with our technicians, find out, to establish timelines when we can travel. So there are some, like I said, there are some restrictions that we have with quarantining and stuff like that that we're trying to work through, but we deal with that on it may delay, it will definitely delay some of the applications, but we will find time to get them done. Contract, I got a question. Define contractors in the field. What we do with the contractors are dealers, or people that we've worked with in the past that we've had training with. We've set up contracts with them to work with us to perform the duties that our technicians would normally do. We have a limited amount of technicians for this type of work, so we try to partner, like I said, make strategic partnerships with certain dealers to perform the work on our behalf. Al is always in constant contact with them, so any any help that they need in the field, Al is available, or any one of our in-house people can help. So what we do, the as far as training, we have we have for it. If you want to be, if you're interested in becoming a contractor, what we do, like I said, we have a in-house, or if we have a certain amount of people, we can come to your facility, and we have a hands-on training, as well as what we did for the previous training was a 2 to 3 day classroom training as well. And then, like I said, the hands-on, and then on the job training will be, like I said, Al will be support for once you're at the application. Once you're at the deployment, Al is available to help set everything up. So there's a question on, is online training available? We do not like to fully allow someone to do these deployments with just online training. You really need to get your hands on the equipment to see how it functions, what types of roadblocks we run into during these applications, and then how to solve them. That's where we really need to have hands-on for a lot of that. Like I said, Al does a good job of showing you what the what's involved in the process, but like I said, until you've run into, if something happens, even equipment wise, if a generator fails, what effect will that have on, if sometimes the generators, they don't fail, but they'll turn off for some reason. So we have to be mindful of every situation. So that's why, like I said, we could do some training online, but really we'd like to get people in the facility working on the equipment hands-on. So
Well, Scott, what we found over the years is that also a lot of people look at this process and say, "Oh, that's easy. I can do that." And then they try and then they fail.
yeah.
So we, we like to train our people and get them up to speed as good as possible. We've spent many years trying to figure this out, particularly the noise monitoring, and to get
Yep.
that to come out right. And it's like we have processes for this, and so which we jealously guard. Another thing that the COVID brought to mind too is a kind of a service that we didn't mention, and that is something we call the Econo SAM, where we can work with you to do the spectrum analysis and monitoring, where remotely you provide the labor of moving the equipment around and getting it to the different sites. I will operate the equipment remotely, and because SAM is not as difficult to get correct. It's not quite as good as full-fledged SAM, where we send our people into the field, but it can sometimes be a good alternative, especially now with COVID, where you can still get some information. We can't do the NAM under those conditions because of the some of the equipment that we use is extremely sensitive, and replaced, and to almost to some extent not quickly replaceable. So if we have a failure with some of that equipment, we're in a bit of a pickle. So we're trying to really protect that equipment to the best that we can. So we don't
Yeah,
let
and
that equipment out of our sight.
we're constantly looking to upgrade. You know, we're recently replacing some of our current equipment with our old equipment with more current models. So we're always looking to upgrade and keep on top of the technology. You know, we've been doing this for, like Al said, you know, 10 to 15 years, and we have some projects that are 3 to 5 sites, but we have several that are 50 to 80 sites. You know, it's very large projects. We're working out in LA on a large project, and up in the upper, you know, Washington area, Oregon. You know, we've been working on a 50 to 60 site project out there. Takes several years, several deployments, but we have a very, you know, like I said, and we've done as small as 1 or 2 sites. You know, we wide range. There's no project too big or too small. So I'm just trying to see if there's any other specific questions we need to cover. We do have a couple minutes, but all right. Looks like Econo Sam. Well, Econo Sam, that's what Al was just discussing. You know, like if anybody has any questions on that specifically, you know, just send us an email. We have literature on all of our services, and you know, Al can answer any technical questions anyone has on any one of the services we have available. So I do have a question. Can your equipment do in-building surveys? Al, do you have any yeah,
We've done in-building surveys. It's not it's basically not a SAM or a NAM type of survey. Most of our in-building surveys, which usually revolved around validating or invalidating booster systems, uh, where it's a boots on the ground situation where we can go around through the building and measure the signal levels and document it and find out, you know, if the system coverage in building is what it's supposed to be or where it may be lacking. The biggest problem with doing anything that might be automatic or remote is the inability to know where you are within a building. That requires, you know, somebody on site to be able to document their location. But we can do it. We've done a lot of interesting projects. We did one for an aircraft manufacturer down in Georgia, which if you know that business, you know who I'm talking about. But to measure problems that they had in their assembly area. Well, what happened is the coverage was fine until they opened the door to move an airplane out that they were finished with, and then the coverage would go crazy. And so we were able to work with them in building to resolve that problem. So uh, it's quite a it's quite interesting to go to a building like that where on the drawings a whole big airplane looks like the size of a toy on the drawing of the building. That's how big the buildings are. So we've had some fun adventures over the years.
all right. Well, like I said, this is the first of many webinars. If there's any questions you have, like I said, you can email the field services at txarx.com or give us a call anytime. Myself or Al or anyone here at the team. You know, we've been around. TXRX has been around since 1976, so we have a lot of experience in the LMR industry and RF as a whole. I'd like to thank everyone for attending, and I hope you will attend future webinars. Like I said, we will reach out to you with the future topics and the timing. So if there's like I said, any questions, just give us a call. Otherwise, thank you very much, and I hope you guys have a great weekend. All right, thank you very much.